Hello, everyone. Thanks for tuning in to a brand new After Dinner Mint series titled Behind the Code. On the show, we welcome Art Blocks artists to share a deeper look into their project's creative coding and process. Today, we welcome Steganon, who joins us to speak about his project Autology. At the end of the show, we'll be asking some questions from the Discord community. Steganon, I'll let you take it from here.
All right. Well, hi there. I'm Steganon, and I'm thrilled to have this opportunity to go behind the code for my Artblocks curated project, Autology. So, a little bit about me. I'm a generative artist with a highly technical background. My bachelor's degree and expertise is in computer science, and I've worked on engineering computer infrastructure and software tooling for large corporations. I prefer to remain personally anonymous, and I really enjoy exploring the confluence of art with technologies like generative algorithms and steganography, which I'll get into during this presentation since it has a lot of importance in ontology. I also hope to eventually delve into incorporating artificial intelligence in future projects. And my pseudonym Steganon is just a portmanteau of the words steganography and anonymous. So as of now, I have two long-form generative art projects that were minted on Artblocks. Autology was released in November of 2021, and Assorted Positivity just came out recently in June of 2022. Autology is a series of 1,024 pieces, and I consider the project a labor of love. It took over 6 months to develop, and the name Autology means the study of oneself. And personally, the project was exactly that in many ways. I've realized that the process of creation is my main driving factor, and I grew so much as an artist with this project. Autology outputs are intended to be a study of themselves in a few ways. The steganographic source code provides a bit of social commentary on blockchain, on-chain art, and data resiliency. Sometimes self-reflection is noted literally and visually, as in the case of Symmetry. There's also a purposeful Rorschach quality, suggestive of the classic Rorschach studies that were, quote, designed to reflect unconscious parts of the personality that project into the visual stimuli generated, end quote. Also, while working on the project, I started seeing similarities to indigenous art, and the anthropological influence inspired me more as an easy interpretation of the study of oneself. I leaned into continuing that aesthetic. A little side note, a collector recently told me that they had discovered the collection the day after a transforming shamanic experience that they had had. And they said that, quote, nailing the indigenous art vibe through code is an astounding achievement. And wow, that was really meaningful to hear. So it's been awesome to know that the art and hidden meanings have resonated with some collectors. So circling back to steganography, for anyone who isn't familiar with it, steganography is the art of hiding a message in an unexpected place. It's not necessarily or even supposed to be encrypted. The goal is to have some sort of message in plain view, yet not have it be obvious that there's a message there at all. One term that fellow computer engineers might be familiar with is security by obscurity, which relies on implementation secrecy as the means of security. It's just obfuscated enough to confuse anyone that's trying to understand it. The first recorded use of steganography was in 440 BC in Greece. There was a Greek ruler who shaved the head of their trusted servant and tattooed a message on his scalp. And once the servant's hair regrew, he was sent to pass on a riddle alluding to shaving his head and revealing that message. And steganography may now be most known for being used nefariously, like malware, or finding ways to avoid oversight from authorities. So it's important to me with my art that I shed light on the positive qualities and potential beauty that it can bring outside of the negative stigma. A relatively recent example of artistic steganography is the song My Violent Heart by Nine Inch Nails, where a hidden image was actually encoded as sound in the song, and it's visualized using a spectrogram pictured here. There. On a side note, about 20 years ago, an early computer security influence for me was a TV show called The Screensavers. My favorite segment was actually hosted by Kevin Rose well before he was an influencer. His hacks guided me to a new realm of computers and helped me focus my interest in computer security, which led me to take courses in ethical hacking, encryption, and steganography, which is when I first learned how to hide messages within images. The concept of steganography was especially intriguing to me, and I recall demoing hiding a copy of my team's source code within the image of our final class project. And I realized after college the computer security careers available at the time, they weren't really for me. So instead, I had a pretty successful programming career. My interest in security, ethical hacking, and encryption popped up in my side projects and hobbies over the years, but it wasn't until I discovered generative art that I thought steganography would be useful in my honest civilian life. As I developed my generative art skills and learned about art blocks and on-chain art, I immediately had the vision that steganography and on-chain art were made for each other. And to my knowledge, I believe I may be the first generative artist to incorporate steganography. And all of my projects so far have some form of steganography. But for my first long-form generative art project, specifically for art blocks, my aspiration was if code could generate a unique piece of art, then the capability of art to generate its source code is an art form in itself. Also, I remember at the time there was a discussion in generative art about whether the output was the art or if the code itself was the art. And with this project, I really strive to achieve both. So working on the steganography was the first thing I focused on in Autology. I used a trick with the JavaScript eval function where the code could write itself into a variable called an eval quine. Quines are self-referential programs that are pretty tricky to write. And with this format, the variable _s is available in the original code here. So you can push the exact code you started with into a string, which can later then be encoded into the image. I then encoded the eval quine into the outputs via LSB steganography, which is also known as least significant bit steganography. And that utilizes the RGB values of a pixel to hide things. A single pixel in a digital image is the combination of 3 channels, red, green, and blue. And each of those channels range from values 0 to 255. The combination of those channels is what creates the final color of that pixel. For example, you can see here this color is a combination of red 93, green 120, and blue 163. But very slight changes in the values aren't necessarily noticeable to the naked eye. For example, changing the red value to 90 on the right here is nearly impossible to discern. So taking that into account, I can go back and first make all the RGB values even numbers, and then use purposeful placement of even and odd numbers to hide 3 bits of information, 1 for each of red, green, and blue per pixel. This can be done strategically, replacing some of those even numbers with odd ones. And with these tiny changes, the color remains looking almost identical to my original color on the far left. Here's a visual example, and it's a fictional digital image close-up containing 9 different colored pixels. If you were to use any photo program with an eyedropper tool, I can note the exact RGB values of each of those 9 pixels. And I can convert those to binary numbers by labeling each even RGB number as 0 and each odd number as 1. And then concatenate all the 0s and 1s together, top to bottom and then left to right, to get a binary string of 0s and 1s. So I should mention that ASCII is a common text encoding scheme that may be represented by 8 binary bits. So in this example, if I think that there is a text message hidden here, I'll split that string of characters into groups of 8, and I'll ignore the final group that's shorter than 8. Then I would convert each group of 8 into ASCII characters and be able to read the hidden message. And there is a short hidden message in this example, but I'll leave it to you if you want to pause the video and figure it out. So I'm going to get a little technical now with the code, but it will be fairly brief, I promise. Here's the function that actually hides the code in the Autology image. Note that the full code is wrapped in an eval quine that I mentioned earlier that I'm not actually showing here. So the FCC functions at the top are simply converting numbers into quotes that would otherwise break the quine. And the _s was initialized as a variable containing all of the code in the initial point. And here I'm adding the token hash to the string and also adding back the string initialization and the eval function to turn it back into a coin. And here's where I convert all of the code to a binary representation in the out variable. And finally, I encode that binary message into the image. And also I add some randomness to the pixels. That randomness adds some texture, but most importantly, it makes the steganography visibly undetectable since every surrounding pixel has some variation. And the whole encoding process is easily reversible. So my original idea was to have code generate the art, and that art could generate its own code, and this could continue in infinite recursion, so the source code would literally be part of the art. A kind of cool note is that the entire Ethereum network could go down, and it would take only a single collector backing up their original image to enable recovery of their token, or even the recovery of the entire collection if people knew their token hashes. I wrote a decoding program for collectors, so anyone can go to my website and decode their own source code. And I can show that to you here. So from the live view in art blocks, click. So we click on the live view, and I already have that up over here. You click S to save the image locally. An important note is that only the live view in Artblocks works. OpenSea and other platforms use lossy compression for their static images, and that removes all the steganography. So once we have that saved, we can go to our saved file and see the embedded source. So this is the embedded source, and it's compressed, so it's quite difficult to read, but that's the source. A really cool side note is it was awesome to hear that a collector actually did their own sleuthing and shared their own decoder written in Python on GitHub. So anyway, after mastering the steganography in my algorithm, deciding on the visual aesthetic was not as straightforward. I was stuck on the name recursion for the project, and the name influenced how I wanted the algorithm and visuals to be. So I had started with a 3D maze algorithm, and I really liked the look of slightly offsetting the whole maze and drawing it several times on the same canvas, which caused a lot of really nice patterns and chaos. I created some really cool outputs like Clout, which is a one-of-one that I ended up creating for Foundation, but most of the outputs weren't interesting enough for a long-form series. So unsure of which direction to go, I kind of put the project on hold and refocused more on education. And I returned to an initial influence of mine, Manolo or Manoloid. I was inspired by his beautiful Delaunay triangulation artworks and quickly realized their relationship with Voronoi tessellations. Delaunay and Voronoi are considered dual to each other. And Delaunay triangulation is a technique for creating a mesh of contiguous, non-overlapping triangles from a data set of points. You can see here with the dotted lines. And a Voronoi tessellation uses the same data set of points as a designated cell point and creates a tessellation of polygons or cells that contain all the space nearest to the cell's point than to any other point on the 2D plane. So here's polygon with that basically in the center. And Voronoi tessellations are also called Voronoi diagrams. So this is a nice visualization of how a Voronoi tessellation is created. Once I realized how ubiquitous Voronoi tessellations are in our lives, it really surprised me that I wasn't familiar with the term. It is applied in so many areas of science and mathematics, and even shows up in nature, like spots on a giraffe. Even honeycombs are a Voronoi tessellation with evenly placed cell points. An easy example to visualize how a Voronoi tessellation is created in real life is a very basic school zone map, where students are able to attend the nearest school to which they live as measured by a straight line distance from their house to the school. So the schools are the plotted cell points, and the school zone is the cell. or the polygons formed around those points. And the map of all the school zones and schools is a Voronoi tessellation. So anyway, at its core, the Autology algorithm is based on Voronoi tessellations. And with some experimentation, it was clear that the plotted points needed some structure to be visually appealing. Basically, I found that incorporating a structure organized of the plotted points proved to be more interesting than any outputs with strictly randomized points. So I created a grid structure to aid in a point placement, which is one of the searchable features in Autology. So the options are a 1 to 6 grid blocks wide and 1 to 5 grid blocks in height, but I normalized the distribution so most were about a 3x3 grid. So the points are plotted inside each grid block in a variety of formations, but they can also be rotated and extend out of their grid blocks a bit, which might make it harder to visualize. Also, some shapes have shapes inside of them. So you could have a 1x1 grid that has 3 shapes inside of each other, and it would be really hard to tell that it's still 1x1. And I'll show more examples of the formations in a bit, but one example is this top piece is a 1x2, 1 width, 2 height, even though it might be difficult to see at first glance that this is a 1x2 because there's something inside of that circle there. So first, a quick overview of some of the evolution of the project that it went through. I played around with adding depth to each polygon and thought I could achieve a more recursive look if I repeated smaller polygons within each polygon. And the project was moving in a hopeful direction, and then as I made a bug fix for something, I accidentally dropped the outermost polygon. I essentially broke the tessellation because there were now spaces between each polygon and the image, as seen here. It was a beautiful mistake and became the basis for the whole aesthetic of Autology. And I had no color palettes yet, but you can probably tell that points are placed in circular formation with repeating points in a circular formation surrounded by those. And the tessellation is broke with a negative space around here in between each. So then this is a sine wave among randomness. Here's the wave. I was also experimenting with the glitch effect, and that's a final feature which I'll explain pretty soon. And I was experimenting with increasing cell spacing and negative space. It was a lot of fun in the months that followed, exploring and experimenting and testing out ideas. So here I added some mirror symmetry and worked on palettes. This was Aurora. I also worked on color placement by creating a color flow maze. Another thing I'll come back to. I envisioned the implicit ways that Voronoi cells could be manipulated and resized, and there were opportunities to include variations of symmetry that naturally promote the eye to draw out faces and fill in gaps. You can see several faces here possibly. The asymmetry also embraced the use of negative space. My hope was for the outputs to evoke conversation, introspection, and some mystery about the magic of generative art. Here's the kitchen sink palette, and I was trying out specific facial experimentation methods, which ultimately got cut before the final algorithm. And this last example shows more experimentation with the glitch feature, point formation, rotations, and noise. The noise or graininess, which I touched on earlier, it's intentional for the texture, and it's created by subtracting a random value 0 through 15 from each RGB channel in every pixel. And even though the LSV steganography is difficult to detect with the human eye, randomizing the pixel values a bit prior to the steganography makes it blend in even more since the neighboring pixels are all varied. As I tend to be working on multiple project ideas at the same time, I played around with my Voronoi algorithm using base images to create generative portraitures. In doing so, I realized there was a bug that displaced the colors in some cells to others. And I really liked this output so much that I ended up creating a 1-of-1 on Foundation, and I released it before Autology. So circling back to color, I developed a color flow maze to determine how the polygons or cells are colored. First, the original connected Voronoi tessellation is used, and a random grid block is chosen, and then a cell in that grid block is assigned a color from the palette. So for example, let's say we start with yellow. From there, a maze is generated as the first color flows through to the connecting polygons. Whenever the flow reaches a cell that has already been colored, another color is chosen randomly from the palette and a new maze path is created from the last unexplored connected cell. The flow of color is easier to visualize by studying these denser Autology pieces. And you can also see that color is not included in the symmetry, though that's not to say that symmetrical color couldn't occur randomly. All right, and so I mentioned a grid. So I can show here how the points are plotted inside each grid block in base formations, like spirals, Bezier curves, and more. Points and formations are generally contained in each grid block. However, sometimes they're allowed to overlap a bit. Tying in the early roots of the project's recursive nature, some point formations may contain other point formations 80% of the time. You can see that in circle within a circle here. Circle and spiral formations tend to resemble eyes when that recursion is triggered. Point formations are also randomly rotated, allowing each grid block to interact to the neighboring grid blocks differently and create unique combinations. So on the left, you'll see the initial Voronoi cell points that are plotted, and here they're rotated. And on the right is the final Autology piece. This is Autology 63, and I'll come back to demonstrate all the stages of the algorithm. And so on to symmetry. Symmetry determines whether a piece is horizontally symmetrical, which is mirror. Sections of the grid are symmetrical, sectional, or if there are no intentional symmetry, random. And no glitch means each polygon or cell is reduced to 60% of its original size while keeping the initial cell point. Minor glitch alters each polygon size to either 40% or 80% of its original size in a 50-50 distribution. And major glitch changes every polygon to a random size between 20% and 100% of its original size. So the absence of glitch in 565 produces organic outlines and curves, whereas 838 and 564 are respectively more blocky and chaotic. Rocky Road creates imperfect organization of certain types of formations, such as Bezier curves. The result is a wider variety of polygon shapes within those curves, whereas the smooth default generally aligns those polygons more evenly. So you can see these have pretty different shapes compared to most of these are rectangles and triangles. So no margin allows polygons to extend off the frame, and a margin maintains a border of negative space, and any polygons that touch or overlap the edge are filtered out. The clipping is most obvious in pieces like 857 here, where just a few polygons are shown in the upper corners. So back to point formations. There are 7 base point formations that happen in each Autology grid block. The first one is circular, and it manifests itself as triangles pointing toward the center. Each point in the circular formation may also be circled by more points, which you can see up here. The next one is Bezier curves. The grid block can include between 1 and 5 Bezier curves. If there's more than one, they are repeated and displaced either horizontally or vertically. And here on the left, you can see the curves are repeated horizontally. You got 1, 2, 3, 4, 5 here, and they all go like this. And the right is a major glitch, which makes it a lot harder to see, but the curves are displaced vertically. You have one down here, one a little above it, one above that. Next is a random fill, which is when points are placed randomly, generally toward the center of the grid block. This creates clusters of polygons that are generally manifested as squares or groupings. And the right has a major glitch. Organized fill is when points are evenly distributed through the grid block, similar to a honeycomb, but they can be offset slightly. The right side is a minor glitch there. Then you have crosses, which are either perpendicular segments. They could be a single segment or even a blank area with no segments. So here, each of these are two segments that are crossed, and this one's a minor glitch on the right. They can also be rotated such that they extend outside of their initial grid area. And the initial points for boxes are at the boundaries of the grid block. Boxes can have 0 to 4 sides, meaning there's a possibility for the grid to be absolutely blank here as well. Additionally, boxes can be rotated and possibly extend out of their initial grid area, which you can see this is kind of a little bit diagonal, extending out of its area. Last is a spiral, where the initial points are laid out in a spiral formation. It manifests itself as kind of a scaly structure. Many of the shapes I mentioned may also have shapes within their shapes, and they can be offset from the center, as you can see in this. Here's a spiral within a spiral. Also note the red color here. It helps you visualize the color maze too in this one. All right, so here's Autology 63 again, and I'll go over the stages of the art generation. So on the left, you'll see again the original points laid out within the grid, which is a 5 by 2. So I can see 1, 2, this would be 3, and then 4, 5, and 2 high. So the circles around the points here have kind of bled into the grid sections that are outside of their area. Is something to note. And then down here, it actually looks like this section was blank. And as we look over here, this is when they're all rotated and they've extended outside of their original grid blocks. So this one here, I think, was probably this here. So if we're starting with the previous stage down on the left, the next stage is to generate the initial Voronoi tessellation from those points. And I've overlaid those points in the red here. This is also where the color maze comes in. You may be able to see how the same color travels from some polygons to their neighbors. You can see like this brown moves around here. The orange comes around. And I'll show one later where it's very visible. So next, the polygon sizes are reduced according to rules based on glitch type. So without glitch, as shown here, it's a static 60% of what it was over here. The plotted points haven't moved, and the polygons always shrink inward toward their initial Voronoi plotted points. To keep the recursion theme, all of the polygon sizes are reduced and lightened 4 more times, layered on top of themselves, like you can see up here versus up here. The sizing of these recursive polygons is also determined by glitch type, and it adds a little bit of height and dynamic texture. And then in this last one, I've just removed the grid points. So this is the final Autology 63. So here's another example with Autology 737. Again, we have the initial points in the grid. This was a 3 by 3 with mirror symmetry. And an interesting bug that I ended up leaving in was when formations are rotated across the center line of a symmetric piece, those formations aren't clipped as I originally intended. So this line ended up turning into 2 lines. So it creates a lot of interesting extra lines and unexpected variation. And with the Autology 737 here, there's a lot happening as the Voronoi cells are filled. Since this piece has a margin, any polygons with edges outside of that margin will be discarded. And here's the one I was saying that I can also really see the color maze. It looks like the black was likely the initial color, and it traveled nearly all the way across the screen before doubling back on itself and requiring a new path. So you can see it from over here. It likely went over here, around, followed this little tiny black one there, somewhere around here, probably went up here, Anyway, here's the path that it looks like it might have crossed. I can't guarantee that, but that's what it looks like. And so from there, here's where the polygons get reduced. And this piece has a major glitch, which means that each polygon was dynamically resized between 20 and 100% of its original size. And we can also see all of the discarded polygons here. So like all of these that were right there, they're now gone. Got discarded from the margin. Then as before, you can see the lighter polygons resized and layered on top of the originals. But note here that there's a lot more variation in the lightness of the polygons due to the glitch effect. So this one's almost totally a really, really bright green that's almost white, where the other one just had pretty statically sized things. And again, I've just removed the red points, the reference points. So this is 737. The owner of this piece named it the Samurai, and I definitely see the resemblance up here. So I'll show some more quick ones. Here's Autology 507. Here's the rotations, the tessellation, and reduction in polygon size, and the final piece. Here's 636. And the final piece. This is 720. And final piece. And I want to do one more just because I really adore Autology 329, and I want to share my thoughts here. So if you're a Rorschach purist and don't want your views of these art pieces being influenced, please know that I'm about to tell you what I see in this piece, so you may want to mute the video for a few seconds. So this one was really a surprise because typically the artworks that promote pareidolia tend to be symmetric. But here as art takes shape, I clearly begin to see a parent tripping while carrying a baby. So the baby is on the top left, laying in a basket while the parent has tripped and begun to toss the basket in the air. I know it's a bit offbeat, but as a parent, the output is simultaneously hilarious and terrifying, and I can't look away. If anybody else sees anything different, I'd love to hear it. You can also clearly see some color paths here, even in the final output. So there's the brown. All right, so I have some exciting news that 2 Autology pieces will be showcased in the upcoming NFT Liverpool event. They will be displayed in Adelia Art Gallery from July 26th through 31st, along with other works curated by Iran and DK, the Cheerful Loop animator. The exhibition was curated by some high-profile names, and styles of work span the whole NFT universe. Divergence team member and co-creator of Brotchain and the Kiss Precise Iran curated Autology 125, also known as the Jovial Owl and owned by D. Bachman, plus Autology 133 owned by the 6529 Museum. Tickets are free and available at nftliverpool.adelia.com, and special thanks to D. Bachman and Punk6529 for allowing me to submit those pieces from their collections. Also, the official prints for Autology are now available via Artix Code. They're great to work with, and each printed piece will also include a nod to steganography. Go to artixcode.io and click the prints link, then Steganon near the bottom of the page. And I can show you, here's the page. It's pretty well laid out. And also please check out and follow the Autology bot on Twitter created by Andre ITR. It's a nice way to occasionally see pieces without being overwhelmed with over 1,000 to look through. Plus it's easy to keep up with secondary sales. I love and support Andre's mission to spread art on Twitter, and all of his art bots are worthwhile following. Lastly, I'll leave you with a handful of pieces that have some notable figures. I try not to provide too much info about what I personally see in each piece because I don't want to risk influencing someone else's perceptions. but many of the outputs look like animals. And there is a common theme with owls. So here are the Autology owls that we found with varied personalities that I have posted this in the past. I'll be doing a ADM with Ponyo soon, and I hope to cover a lot more of the visuals with over 1,000 pieces. It's a lot to see and discuss. So here's some other notables. The owner of 197 on the left named that one Kitty. And on the right, we call it the Calico Cat, since that's the palette Calico. Most people tend to see aliens here. On the left, I see like an alien from the movie Aliens skating or something like that. Autology 872 is in my own gallery. It feels like piano keys in its design due to the combination of Major Glitch and the monochrome palette, and it's very calming to me. And last but not least, Autology 232. This combo of heart-shaped lungs was an amazing and welcome surprise, since the primary donation was to the Lung Cancer Research Foundation. All right, so thanks so much for watching. Hopefully it was informative and somewhat interesting, even for those who don't understand code. As I said, I'll also be recording an ADM with Ponyo soon, and I'll likely cover some less technical Autology topics and talk a bit about my latest art blocks release, Sorter Positivity. And I'll open up to any questions at this point.
That was super informative. I'm kind of blown away with how much I just learned, to be perfectly honest. So much went into that. And so first I want to say congrats on the NFT Liverpool exhibition.
Thank you.
I love the mints that were selected as well. So first question is gonna be from Big Bird. It's in relation to palettes. He was asking a question broadly. I know you touched upon your selection broadly as well. And so I asked him if he had a specific palette in mind, and he asked kitchen sink with black background is his mint. So if you could share more details about how that was incorporated.
Yeah, so I can actually pull that up on my website. I think I touched on that. So the kitchen sink was actually from some artwork that I came across by a person named Jimmy Pike. And he's just really used some really colorful things. The kitchen sink palette has 8 colors, which is the most of any of the Autology palettes, and it was very much inspired by this artwork that I'm showing right here, the Rainbow Serpent. I came across this when I was researching indigenous art, when I realized how much that the Autology artworks just on their own look like indigenous art. So I did a lot of research on that and how I could kind of get a nod to it. So yeah, I was really inspired by this piece here, the Rainbow Serpent.
Cool. Ixnay OK has another question that's palette related. So he said, I'm interested to know technical details of how the palettes are implemented. Like, for example, various Calico palettes have different background colors. Are the various colors in a palette used in different ways for different outputs with the same palette? And then he said, I see there's a separate background feature. Is the background picked from the palette or determined by it somehow?
Yeah, so there's 2 options. It could either be a black background or a color from the palette. And it's a little complicated to say because the palettes are, maybe it'll help if I go back to one of the, what did I do? Sorry. So if I go back to one of these here, like this one, for example. Autology 63. So here in the beginning, a color is chosen from the palette, and it's basically pulled out of that palette, can't be used for anything other than the background. So this brown, this dark brown, was initially a color from the palette, and it's been designated to be used only for the background for this piece. And all of the other colors are used within the maze that I mentioned earlier. The place where it gets a little complicated is when these, if you look at the top right here, where my cursor is, the colors, it's still using that same color from the palette, but it's changing the lightness of it to get lighter and lighter as you go smaller. So I think this one had 5 colors initially. I don't know if I can count them right now, but one would have been used in the background. 4 are used throughout here as they get lighter as well. So it's a little bit more than 4 colors, but the initial palette is 5. It's a long-winded answer, but
No, I think it makes sense. And then he had 2 other parts of the question. One was, are these made with Voronoi cells, which I know you touched upon. So I think he'll learn about that earlier in the presentation.
Right.
And then the third part was, how do sectional and random symmetry differ? It's not immediately clear from looking at outputs.
Right. So sectional. Let's see if I have a sectional in one of these. So like this one, I believe is sectional. I haven't looked it up, but I believe it's sectional where random, each block is totally random as to what shape is going to be in it, or shapes is going to be in it. The sectional actually has sections of that grid which are a mirror. So right here, I think what probably happened is this was a 2 wide, 3 high, where this top 2/3 was actually a section that was mirrored, and the bottom one would have been random. So it's sectional is part of the image is mirrored, and the rest is random.
Cool. And so this is a question from myself. I know with this project, it seemed like the sonography came first, followed by the imagery. And so
Right.
Is that how you always work? You'll come up with the sonography first?
Not necessarily. I mean, trying to think. So the one I did right before Sorted Positivity, which was called Lost in Thought, I had an idea of what I wanted to create from the artwork, and then once I was done with that, I was like, I want to add some steganography with this to keep my streak going, basically. So I added some steganography to that after the fact, that I'm still waiting for somebody to find, by the way. But no, it's not always a formula of steganography comes first.
Makes sense. And then a final one is from Sklez. He actually asked about your loss in thought, but I wanted to kind of tie it into autology and assorted positivity. And I guess just the evolution over time. So this was your first project, long-form generative art, including sonography, correct? And then I guess, how did you approach it different? And I know it's brief, and I know you're going to be hopefully doing another one with assorted positivity, but I'm curious how the evolution kind of went to each.
Wow. So the first one, like I said, it was like a 6-month-long learning experience. I had a full-time job on top of it. So that was some long nights and a lot of learning. And then since then, I've moved on to doing generative art full-time. So I've spent a lot more time learning now. And the assorted positivity, I hadn't learned any WebGL prior to Autology, and assorted positivity, that's what it uses. So it's a big learning curve, and I definitely want to keep pushing myself to learn more stuff and getting better at what I now newly do. But yeah, it's a constant learning experience, and I love that.
And I love hearing that you're able to be a full-time generative artist too. I think that's amazing. Awesome. That's all I have from myself and the community. Is there anything else you want to include? Otherwise, thanks to everyone who will be watching this. I'm not sure exactly the date it's going to go live, but I want to say in about 2 weeks. Okay. And thank you, Steganon, for joining and presenting. And like I said, I learned a lot about this project that I didn't know before. So awesome. I think listeners will really appreciate it. And until next time, be great. And happy minting, everyone.
Yeah, thank you. Thanks for having me.
Awesome. See y'all.